All right, example one wanted us to um, use right triangle similarity to write a proof of the Pythagorean theorem. So we're given that triangle XYZ here is a right triangle, and we want to prove that a squared plus b squared equals c squared. So we probably need to put that in as well. So the two legs are the a and the b, and then your hypotenuse is your c. Okay, so we want to prove that a squared plus b squared equals c squared. Right, so the first thing we're going to do to solve this is we're going to drop in an altitude. So we're going to draw a line from the vertex here, point x, um, so that it is perpendicular to the hypotenuse here. And let's just call that point W. Okay, so C is the length of the hypotenuse here, just so we keep track of that. And then we're going to call these pieces D and E. We can call those two pieces D and E. Okay. Um, and so what we have now are three right triangles. So we dropped in an altitude, and now we have three right triangles, the big one and the two small ones. So what I'm going to do is I'm going to draw each of those separately so we can see them. So I'm going to draw the big one in the middle. Okay, that is x, y, z. And so the sides of that are A, B, and C. Lengths A, lengths B, and length C. All right, now I'm going to use a different color here, and let's draw in the other two triangles. So I'm going to draw in this triangle here. So W is the right angle. And then you have x, and you have y. So the lengths of this one, um, we have the hypotenuse xy is going to be a. And the length of yw we said was d. You can also draw the third triangle here in blue. So we have a third triangle, right triangle. Again, w is your right angle, and x and z, right? You got to kind of flip it and rotate it a little bit. All right, so the length of xz here is b. The length of wz is e. So all we've done here is we drew an altitude, right? So we had A, B, and C in our big right triangle. We drew an altitude, and we split C into two pieces, D and E. So then we drew the three triangles separately, the big one in black, and then the top one here in red, and then blue. So we have our three triangles. We can start working here now. Okay. So let's look at the first two triangles here. Okay. If we notice we have one pair of angles that are congruent, we know angle W is congruent to angle X. Right, that was our right angle theorem. All right angles are congruent. And we also know they have an angle in common. They have a shared angle, and that's angle Y. Angle Y is both part of the red triangle and the black triangle. So angle Y is going to be the same measure in each triangle. So we can say angle Y is congruent to angle Y. And since we have two pairs of angles that are the same, right, we can use angle-angle similarity, right, to show that these two triangles here are similar. So triangle YWX is similar to triangle YXZ. Right? So our triangles are similar. So if our triangles are similar, we know the sides are proportional. So we can set up a proportion. So we know A here is going to correspond with C, right? If the triangles are similar, the sides are proportional, so we can set up a proportion. So we know A corresponds with C in the other one. And then we know D corresponds with A in the other one. So we have A over C equals d over a. We know to solve a proportion we can cross multiply. So if we cross multiply, we're going to end up with a squared equals c times d is cd. And we're going to leave it at that. And now we're going to come over here and look at the next two triangles. Okay, so we know angle x. We're going to look at the blue and the black now. So we know angle x is congruent to angle w. And we know they have angle z in common, right? Angle z here is part of both triangles. So we know by angle-angle similarity. So we know angle z is congruent to angle z by the reflexive property. And then we can use, again, angle-angle similarity to say that these two triangles are similar. Triangle yxz is similar to triangle xwz. And since those two triangles are similar, we know their sides are proportional. So we know that b here is going to match up with e. So b over e is going to equal c over b. And then to solve the proportion, we cross multiply. So we're going to end up with b squared equals c times e. And so we have two equations here. And what we simply want to do is add our two equations together here. So we're going to add a squared equals cd. We're going to simply add that to b squared equals ce. We're going to add these two equations together. And that's going to get us a squared plus b squared equals cd plus ce. We can factor out a c here. So we're going to be left with a squared plus b squared equals c. We're factoring out the c, so we're left with d plus e. Slow here. Sorry about this. And then since we know d plus e is going to equal c, kind of running a little bit out of room here, we're going to have a squared plus b squared equals c times c. And c times c is c squared. So we're going to have, if I move this over here, a squared plus b squared equals c squared. Times c will give us squared, right? And that's what we were trying to prove. So we are done. Okay, so we just drew in an altitude, right? So we ended up with three right triangles. We drew the right triangles separately. We found out by angle-angle similarity, actually all three triangles are similar, so the first two are similar. Therefore, we set up a proportion, a over c equals d over a, so that we cross-multiplied and got a squared equals cd. We used the second two triangles. We had angle-angle similarity, so the triangles were similar, and then we set up a proportion, b over e equals c over b. We cross-multiplied, that's b squared equals ce. So we had these two equations. Okay, and then we simply added those two equations together, a squared plus b squared, and then cd plus ce. We factored out the c, and then we know from our diagram d plus e up here equals, should have backed it up a little bit, d plus e there is going to be c, the length of the original hypotenuse, and then c times c is simply c squared. So we've shown that a squared plus b squared equals c squared.